Well, thank you very much. And it's been smashing to sit here and find out about Hereford and the Ice Age ponds. I seldom get the chance to spend all day talking about and thinking about ponds. So many thanks for the invite. I want to start off with this view. I have no idea whether Hereford in the immediate end of the Ice Age looked anything like this. Looks quite like Newcastle on a Saturday night where I live. There's a pond tucked away in the bottom right-hand corner. What I want to do, although I suspect I'm talking to an easy audience for this, is first of all to look a little bit about the status of ponds and why we disregard them, and then a bit more about ponds and carbon capture. Next slide, please. I mean, this is a quote from a mid-20th century freshwater textbook that has dogged my career. The study of ponds has been greatly neglected. Well, that's true. It is, moreover, a field particularly suited to the activities of the amateur, whose humble pond hunting, if carried out simultaneously and carefully, may well result in valuable contributions to science. Which, given the world I work in, and if you want to conjure up a mental picture of the head of my faculty, gazing over his glasses and thinking exactly the same as he looks at me and what I do, that's my career in tatters. Because I know what people think when you say you work on ponds. Next slide, please. They think, well, it's not exactly the Large Hadron Collider, is it? There is the Large Hadron Collider, and it doesn't really look like pond science. I grant you the Large Hadron Collider is fascinating science, but it is a bit of tech that was once brought to a clunking halt by a bird dropping a bit of croissant down one of its exhaust chimneys. So that never really happens with ponds, does it? Next slide, please. And this is the sort of thing I get all the time. People, this is the sort of thing that pond people do. It's a quiz in BBC Wildlife magazine. And it's a bit like those old-fashioned spot the bull competitions that you used to get, especially in newspapers, where you had to locate where the bull might be in a football match. But here it was, where could the water scorpion be? There's a water scorpion lurking in the bottom left. And you were supposed to use your skill and judgment as a pond expert to work out where it was. And there's quite a nice prize on the right-hand side there, a nice digital watch with maybe aimed at kids, but I'd settle for a watch like that. And that's always been the problem with ponds. They're familiar, they're everyday. People kind of dismiss them because some are made by people. Everyone's fallen over in one. They've always been sort of overlooked. Anyone listening to the talks this morning and just now hopefully would have their mind changed. Next slide, please. And really, if there's two defining habitats on planet Earth, one is the oceans because of their extent, and the other is ponds, because ponds occur on every continent. Yes, they do occur on the Antarctic too, a bit polluted by penguin poo, but you can find them in all sorts of places. These are just some examples, picked fairly at random. Pond there in the top left on the agricultural fields, central USA, a dried up pond there from Spain. People say, well, how can it be a pond, Mike, if it's dried up? It's just a pond without water in it. It's perfectly okay. Tiny little pond like, they're called Phytotelmata, over in the top right there, with all sorts of things living in the bases of bromeliads, high in tropical rainforests. Bottom left, there's a very new pond on top of a glacier. And in the middle there, some tortoises on the Galapagos Islands. You know, one of the most far-flung specks, tiny oceanic islands, you will find ponds. And there's a lovely paper there, bottom right, overview on the formation of paleo lakes and ponds on Mars. Oh, we haven't got time for the Martian ponds today. Never mind. Hopefully you get the message that ponds are a characteristic habitat of planet Earth. Next slide, please. Still, though, they don't get their fair share. Here's a graph from a very recent paper led by Matthew Hill, who works at Huddersfield University, just looking at the academic literature, searching for papers that have the word ponds and biodiversity, and there are a few other similar allied words. And you can see there, even in the last 20 years or so, that work on rivers dominates, streams even, and lakes. I have nothing particularly against rivers, streams and lakes, but they're not ponds. And you've heard plenty of beautiful data this morning explaining why ponds are these biodiversity hotspots. So ponds don't get their fair share of attention, despite the fact that they are so numerous. And it's that abundance that provokes very interesting speculation. about 10, 15 years ago. Next slide, please. And this was some work by an American, John Lawton, and he wrote a couple of papers in the late 2000s, essentially suggesting that ponds could be really important carbon sinks. And he basically took two pieces of information: the sheer abundance of ponds, and he tried to work out the area that ponds might occupy on planet Earth, and also the intensity, the sheer speed with which their geochemical activity occurs. And essentially, the smaller the water body, from big lakes down to small ponds, the more intense the geochemical activity is. And he ends up one of his papers by saying carbon sequestration by ponds may be as great or greater than that of forests, grasslands, and all the world's oceans, which is a dramatic statement. There is Downing's estimate of the area that ponds occupy on the planet, 0.8 billion square kilometres. Now, those of you able to do the quick maths will realise that is larger than the land area on planet Earth. But never mind, because it still provokes a lot of interest. And I've got data like that, and compared to some of the extrapolations I'm going to make in a couple of minutes, that's nothing. My main concern with the work was the estimates of carbon in ponds, in their sediments, and how quickly it was being buried, mostly came from systems like that in the photograph, agricultural impoundments. Often quite large systems, quite enriched systems. There wasn't a lot of data from what you and I would think of as fairly natural ponds out there in the landscape. Nonetheless, really neat idea that caught people's attention. Soon after, some other papers started to come out talking about the gases and how they were coming and going in and out of the ponds. Next slide, please. And here is a kind of interesting pushback from Meredith Holgerson and Pete Raymond over in the States. And they were studying the gas fluxes. So this isn't the actual amount in the sediments or in the water, it's how much carbon dioxide or methane is going in, coming out of the ponds. And the graph there on the right-hand side comes from their paper. And essentially along the bottom, on the left-hand side, you've got small ponds, the right-hand side, large lakes. And I'm less fussed by the precise figures, more the size of the vertical columns. This is an estimate of the amount of methane being pumped out into the atmosphere of planet Earth. And you can see that that left-hand column, the small ponds column, is very considerably taller than the other columns. Holgerson and Raymond essentially make the point that ponds, very small ponds, represent an important inland water carbon flux. They are pumping out methane. So we've got Downing suggesting that ponds could be a really good carbon sink. And we've got Holgerson and Raymond coming back and saying, actually, these systems are pumping out methane. Though Holgerson and Raymond are primarily talking about tundra type ponds. There's clearly something going on here, and this provokes some work mostly done by postgraduates at Northumbria about 10 years ago. And I'll just take you through some of the key results. As I say, hold on to something solid and fixed to the floor, because there will be some shocking extrapolations. Next slide, please. Here's the team. There's Scott and Pete and Dave on the left-hand side. Sometimes it was sun-kissed and sometimes it wasn't. And we're going to talk a little bit about sediments, about burial rates, and about gas fluxes. Next slide, please. First of all, burial rates. Now, I work mostly on very small ponds and pond invertebrates, and I had some very small ponds on a site in Northumberland with precisely known age. I know when they were dug because I dug them. I can tell you when they were dug to the nearest morning or afternoon about 20 to 25 years ago. And it was David suggested, well, if we've got these ponds of precisely known age, Mike, we could dig out the sediments that have been laid down since they were dug. And that will give us a very clear idea of how quickly organic carbon is being buried in these ponds, tiny little ponds. And there we are, that's Pete digging out spade chunk after spade chunk from the bottom of one of the ponds, block by block, literally excavating the sediment of the pond, whose creation date we knew precisely about 20 years before this excavation. Next slide, please. Now, First of all, I think on the left-hand side, there's a panorama taken by just putting a camera down into the pond as it's being dug out. And hopefully you can see there's a slightly brownier bottom layer and a slightly blacker top layer with a divide between them. These ponds were dug out originally on old clay backfill from an open cast coal site. So that's what the brownie layer is. And you can see the black layer, that's the accumulated sediment that had accumulated over the 20 years before we dug the pond out. Now, all the samples, and I'm very happy if they're open access papers, drop me an email, happily send you all the sort of complicated background tech. But essentially, to focus on the key issue about the rate at which carbon is being buried, there's a table there just with a few examples for other fairly familiar habitats. And these things are routinely given as tons of organic carbon per hectare per year. And there's the figure from our little ponds in Northumberland, about just over 4 tons per hectare if you had a pond a hectare that was similar. Compared to temperate forests, hay meadows, improved grassland, they are burying carbon at least as fast. And the figure I've given you is our average figure, it's not our highest figures. The improved grassland figure maybe looks a bit odd. It's got a plus sign in front of that, 0.025. That's because it was the examples taken from various recent summaries were giving out carbon. So broadly speaking, it looks as if our ponds, unsurprisingly, because they're like mini wetlands, aren't they, are burying carbon quite fast. So far, so good. That's a fairly good news story. Next slide, please. What about the actual carbon in the pond sediments? Never mind how fast they're burying it. What is stored? And this, again, like lots of the work we've heard about, involves coring. And there's Pete and Dave and Scott that using a core where we could put it down into the sort of 20, 30 centimetres of a lot of the ponds we were working on in Northumberland and elsewhere and squeeze out centimetre slices. I must say, I'm seldom in these pictures taking photographs. I did most of the photography. That's because Scott in particular worked as a bouncer while he was doing his PhD. So he was perfectly designed for taking cores through almost any kind of sediment. So what do we find? Again, rather than going into detail about the lab analysis, let's cut to some of the results of what we did. Next slide, please. Because we thought we had a clever plan. We thought, right, we'll take some samples from ponds in Northumberland, right in the middle of agricultural fields, top left there, slap bang in the middle of a field that's ploughed and planted every year with wheat or barley or oilseed rape. We thought we'll take some samples from, you can't even see it, the pond in the top right photograph that's hidden away in a beautiful bit of natural wetland. Or, bottom left, ponds amongst sand dune systems, very slight brackish influence, very sandy substrate. And bottom right, ponds that were pasture, where sheep and cattle and horses, and in one case, llamas, could access the pond. We thought we're bound to get really big differences because the animals and plants in these ponds are very different. And we also went to 3 other places in the UK, Askham Bog, which is a lowland peat bog in Yorkshire. We went to Thompson Common in Norfolk, on the grounds that it's perhaps one of the warmest, hottest, driest parts of the UK, which I can tell you Northumberland isn't. And we went to the Lizard Peninsula in Devon, whose ponds can be classified as Mediterranean. So we're trying to stretch the variety of ponds, and we thought we are bound to get very different measures of carbon from these systems. Next slide, please. And here, perhaps, is one of our key graphs. So I'll spend a bit of time talking you through it, but essentially up the left-hand axis there, that vertical axis, we've got the amount of organic carbon. And in this case, it's represented as the amount in a little sort of centimetre cube. It's in milligrams, but I think it's more the sort of relative measures that are important. And I know some of you will be familiar with these kind of box and whisker plots, but don't worry if you're not. Along the bottom, we've got sets of samples from 7 places. Askham Bog, fairly northern but lowland peat. The Lizard Peninsula, very strange geology, Mediterranean ponds. On the far right, data for Thompson Common in Norfolk. And then the 4 sets of ponds in Northumberland on arable, dune, natural or pasture sort of landscapes. Now, there are some statistically significant differences, in particular the lizard ponds are low in carbon. But what really threw us, we spent about a week scratching our heads because scientists I know are supposed to be objective sleuths, hunting down the truth with rigorous indifference to whatever the results tell them. But we were a bit startled by this, especially for people doing their PhDs. They're sitting there thinking, oh, there's not the easy story here, is there? They're not that different. Those grey rectangles, I think the key message of those grey rectangles, that's where the bulk of the data lie for each of the sets of ponds. That's where 50% of the data lie. The whiskery bits of the stars and the little circles are outliers. There's a lot of overlap. We were really taken aback by how much overlap there was. We thought the ponds in Northumberland were all going to be very different. We thought they were going to be spectacularly different to Askham Bog and the Lizard and Thompson Common. Instead, in all of the places, in all of the land use categories, there were individual ponds that had very high carbon sediment and individual ponds that didn't, with the possible exception of the Lizard, all of which turned out to be low in carbon, very thin soil over very strange geology. So that threw us for about a week, but it also led to an opposite approach. Next slide, please. We thought, okay, if there's so much overlap, let's lump them all together and come up with a UK generalisation of how much organic carbon there is in a 1 metre square by 20 centimetre deep block of pond sediment. Do I think that 9.38 kilograms is perfectly? No, I don't. I mean, what I think is there's not 90 kilograms in a 1 by 1 metre block, and there's not 0.9 of a kilogram in a 1.1 metre block. I think it's given us a ballpark target to shoot at. And again, I think it's the comparisons that are useful. So there's a table on the right-hand side for some fairly familiar landscapes: mixed woodland, neutral grassland, heathland, floodplain, samples taken to roughly the same depth. This is taken from Natural England's recent report, with their range of organic carbon in tonnes per hectare. So there's our overall figures. And again, a bit like the burial rates, our overall figures do well compared to most other terrestrial habitats. They're broadly similar to a lot of the sort of more wetland habitats. Now, even though I'm a bit dubious about 9.38 kilograms in a 1.1 metre block as anything other than a ballpark figure, you could work out for the Hereford ponds, maybe, a figure of how much carbon they've got in. And sadly, there isn't a carbon market that pays farmers directly. Wouldn't it be nice to say to a farmer, those ponds, they're worth this? That's how much carbon they're storing. It at least gives us something to play with. It gives us a start. And I think that 9 kilograms is a useful ballpark figure. It needs a mass of more data. As I say, we tried to stretch as far as we could in the time available across ponds where we thought we would really push the differences, and they weren't as different. Maybe the Thompson Common ponds could be a useful comparator. So we've got reasonably high burial rates. We've got reasonably high organic carbon stocks if you lump all the ponds together. What about gas fluxes? Next slide, please. Now, gas fluxes were a main part of what we did, but here's a basic example. Here's Peter, and you can see it's got a sort of floating Tupperware chamber on a little bit of pond. Hopefully you can see the blue and red leads that suck the gas out into that yellow thing, which is a very expensive field portable gas analyzer, which thankfully we didn't drop into the ponds. And it will give you live measures, almost minute by minute, of the carbon dioxide and methane changing in those floating chambers. So what are these ponds doing? Next slide, please. Now, again, just quite a lot of detail here, but let me just talk you through, starting off with that left-hand picture, which is an aerial view of the site where we were working with these very little ponds that we had completely sort of permissive access to do what we wanted. And there's a sort of picture above the tilted version, so you can see them in situ. Now, the tilted version, hopefully you can see the squares, the little dugout ponds from about 20 years ago. And the graphs to the right-hand side of it are east-west, north-south graphs. Each circle is one of the little ponds, its position in the field. And I just put red circles around 3 of the ponds and red arrows pointing to the circle that represents that pond in the graph. So hopefully you can just get your bearings. And the key point is what is happening to these ponds as we went from day 1, day 4, day 9, day 12. This was a sequence of measures because we could camp out overnight in these ponds, in this field. Sequence of measures as the ponds dried out. Now in day one, there's lots of stippled or checkered circles. I'm less fussed about the size, that's the amount of gas, but it's the stippling or checkered. Those were sinks. They were taking in net carbon dioxide. And you'll see as you move from day 4 to day 9 to day 12, right across the graphs, more and more ponds become grey or black. Those are net sources. Ponds very close to each other, these are small ponds in the same field, could be doing very different things, sources or sinks, and they could change very quickly, sources or sinks. It's an unusually detailed data set, but it again is just one small set of ponds in one field in Northumberland. But it does raise some questions, doesn't it, about how quickly these sites could change from being sinks to being sources. Now, again, the data for the burial rates, the data for the sediment carbon and these flux data are all available and they've all been published. If anyone wants the more detailed versions, please feel free to get in touch. So 10 years ago, I thought, right, no, this is really interesting. It does look like ponds could be a real help. And I don't think ponds are ever going to solve climate change, but ponds are quite easy to create. You can stick them into all sorts of landscapes. They do very well. There's nothing complicated. You get quite quick results. There's all this talk about reforestation and tree planting, but we don't want to miss ponds out again. Next slide, please. But that was 10 years ago. And it's funny how things can change really quite quickly. Remember that paper by Meredith Holgerson and Peter Raymond and methane fluxes. Now, we couldn't pick up any methane coming out of the little ponds when we measured the fluxes. The kit would do it. There just didn't appear to be any that was enough to pick up. But there is now very good evidence from ponds around the world that they can be substantial methane sources. So there's some examples, again, chosen to sort of stretch the examples. Rural stock ponds in Australia. So ponds that are created for cattle and sheep. Now you might think, well, that's a bit like the impoundment ponds, isn't it? They could be quite enriched. Maybe it's something to do with the enrichment of the animals getting into the ponds and plodging around and pooing in the ponds. Temperate woodland ponds in the northeast United States. They're not particularly disturbed, potentially methane sources. Arctic tundra ponds. This is the pond systems, the pool systems that have attracted a great deal of attention, since there appear to be a lot of them on permafrost sites, frozen sites. What happens as they thaw? And there's plenty of other systems, some of them urban, some of them rural, some of them tropical, some of them temperate, that suggest ponds could be really significant methane sources. So having started 10 years ago feeling quite optimistic, and then 5 years ago thinking, I've got this cracked, right. Now, very recently, this extra data is coming through. And then I was watching television a couple of years ago and my heart sunk. Next slide, please. Because I started to write things. There's an example there from a public science website. I'm not quite sure why they chose water lilies and goldfish, not the picture I would take. So this was starting to get a lot of attention. These data they've been used by Natural England, British Ecological Society, organisations like that, simply because there doesn't seem to be any other data. And there's some beautiful little ponds there in a corner of a farmer's field in Northumberland, just the sort of place you could sneak some ponds in to add to the wildlife, to add to the aesthetic quality of the landscape, and to mop up carbon. This really good news story. And I'm sitting there thinking, yeah, this is going okay. And next slide, please. Many of you may have seen David Attenborough's programme, Climate Change, The Facts. It's on iPlayer and the BBC, you can still catch it. And it was a very thoughtful programme, full of detail, very well presented, showing a lot of the background to climate change and the issues it presents us with. And then a bit towards the end, David Attenborough starts talking about the millions of lakes in the Arctic. And the camera points down at some ice you can see through, and there are bubbles underneath the ice, trapped. And a scientist walks out on the ice, another scientist with a sort of flaming torch, and Game of Thrones stylely, one scientist smashes through the ice, the other waves the torch over the hole, and you get that whoomph of methane catching fire and coming through. And the camera pans back as ominously David Attenborough talks about the millions of lakes and the methane burp. And there's a screenshot of what was being shown. Now, I haven't got precise measures, but it looked to me worryingly like a pond, not a lake. And I would hate to think people are suddenly going to sit there thinking, these ponds, they could be significant methane sources. That's a worry. Next slide, please. Now, thankfully, there's a big new European-wide project going on, linking all sorts of units. We're not directly involved in this at all, but it includes places in the UK, Freshwater Habitats Trust, Carl Sayers, a group in Norfolk. So it's right across Europe, trying to put together, in particular, the issues of the gas fluxes, of which there's lots of measures, and they've been heavily studied, but the people that tend to do the fluxes tend not to be the same people who are doing the chemistry, sediment chemistry, the kind of data that we've got. Although the data we've got is so small, it's so limited, it's handfuls of ponds, but it appears to be all there is in terms of sort of natural pond systems. So hopefully this project, which has just started over the last year, pan-European, measuring gas fluxes, measuring the carbon in the ponds as well, will start to put this joint together so that there won't be this gap between the gas flux and the carbon in the sediment, the carbon burial rate data. Fingers crossed, one to watch. Next slide, please. Now, maybe we wouldn't be too surprised that methane comes out of ponds. This is a picture by the pre-Raphaelite artist Ford Madox Brown, which is in Manchester Town Hall. And it shows the eminent British chemist John Lawton, who in about 1815, roughly speaking, was going round ponds, and I think we can all agree that is a pond. You can probably identify some of the species of plants in it. Now, that isn't water plantain and lesser duckweed, I don't know what it is. And he is collecting what you would think of as marsh gas. He's stirring up the sediment, and there's a helper there, a field assistant with a jar ready to collect the bubbles. So there should be no surprise. We've known this for a very long time. He was collecting the gas to help with his groundbreaking studies on the structure of molecules. Next slide, please. So if I could try to pull together some of the threads of this very quick romp through a lot of fiddly science, I do think ponds are significant to the plumbing of the carbon cycle globally. I think John Downing was onto something, that there's probably not as many ponds as he thought. There certainly aren't, but they are everywhere, in all sorts of habitats, in very large numbers, doing all sorts of different things. They are significant. The actual amount of carbon in ponds, well, you can scale it up from the data that we've got. You can get estimates of how many ponds there are, how much carbon. Not great, huge in absolute terms, because the ponds themselves don't cover a very substantial area compared to habitats like woodland or grassland or agriculture, but they kind of punch above their weight. I think the burial rates are high. And despite the limited area that ponds cover, if you sort of scale up their burial rates by their area, they are punching above their weight compared to woodlands, grasslands, and similar habitats. We need to be using ponds. We don't want everything. I'm nothing against trees, I quite like trees, but if we focus entirely on trees as a way of mopping up carbon, there are other ways. Things we've got to get to grips with. We've got to get to grips with spatial and temporal variation. Different ponds, even ponds that are close together, appear to be doing quite different things. How do they change? How does their behavior change through time as they wet, how do they dry, especially for methane? Also, what type of ponds would be good? Could we actually create ponds and plant them to be very effective carbon traps? I'm asked this quite a bit. We only have very limited data, even more limited than our normal limits. The ponds, the tiny ponds we dug up for burial rates, I had very good data on their drying and wetting and on their plants over the years. And there were some variations. It depended on particular plants, and it could be that certain plants exude chemicals from their roots, which mobilize carbon out of the sediment. Other plants, they really don't decay. And some of the ponds had a very grassy, mossy bed that even when they dried up, kept the sediment moist and kept the carbon trapped. But that's no more than anecdotal speculation, I'm afraid. So hopefully I've given you some important and useful information. Treat it skeptically. It gives you a flavour. Ponds are important. They do contain significant carbon stocks. They're better than woodland and grassland and a lot of other typical terrestrial habitats for mopping up carbon. But we haven't quite got this link between the gas fluxes and the carbon in the sediments, or the spatial and temporal variation. Hopefully that's something that's useful for you to know. But I know what you really want to know. One last slide, please. You want to know about that watch, don't you? Did I win it? Because analysis of variance and canonical correspondence, I could conclusively demonstrate that the water scorpion should be living in F6, which was a blow, because apparently the answer was K18. And the watch was won by a 9-year-old in Plymouth. Ladies and gentlemen, if that hasn't entirely shattered your confidence in everything I've had to say, it's been a treat to come and hear you. Come to talk to you like this. I'm sorry I couldn't be with you, but I've loved the talks this morning. Absolutely fascinating. And thank you very much for the invitation to join in. You're always welcome to email me. And of course, I try my best to answer any immediate questions. Thank you.
I really enjoyed that. Will, who's going to give our next talk? I'm hoping he's coming forward.
Ask a question.
Yes, we have got, well, we'll get set up.
We're encouraged to plant trees. Should we be digging ponds instead?
We should be doing both. Tree planting, I think, looks spectacular, and it's something that very suitable for many places. So, for example, up where I live in Northumberland, you can tell from my accent I'm not from here, but I've lived here a very long time. I love Northumberland, a wild and mysterious place. There are plans for a big new forest of the north with substantial tree planting. It is perfectly possible to have ponds in amongst that. A long time ago, I surveyed a lot of ponds in Scotland in forestry plantations. The ponds were beautiful. So please put ponds in as well. Think of all the other benefits you're going to get. The wildlife hotspots, not just aquatic life, but the pollinators, the bats, the farmland birds. People love ponds. So yes, by all means plant trees, but there are plenty of places where a pond would do better. It's easier, it's quicker, you get more instant returns, let alone all the other benefits. So go for some ponds.